Hi everyone, I'm Giulio Domina, and in this presentation we are going to talk about the use of machine learning for enhancing the probabilistic prediction of Etna volcanic events, hosted by GARR and the National Institute of Geophysics and Volcanology in Italy. About Mount Etna, for those who don't know, is the highest and most active volcano in Europe, also one of the most studied around the world with a lot of research and data. There are 1 million people living on its flank and thousands of tourists visiting its summit area every year. A lot of important infrastructure, airport, freeways, and social and commercial activities around. So it's a key issue for risk mitigation and civil protection purpose to predict a eruption. During my research, I'm going to create a new early detection system that predicts with some hours before an eruption, improving our current system Etna's decision-free, and also improving the decision-making operational process that occurs during and after, before, during, and after an event. The methodology is divided in 3 steps. Step 1, context analysis. Step 2, data engineering. Step 3, model construction. Step 1, context analysis. I'm doing a preliminary research, studying the state of art, finding an interdisciplinary collaboration team with different minds from different fields of research. Doing so, we can find the theoretical and practical constraint, for example, limit of the model of the data sensor, and also identification. We need what is really useful for us, for the research and the institution. Step 2, data engineering, which is the most important and delicate part of the research. The aim is to represent with data the reality as much as possible, so the model can generalize. We have to extrapolate a new dataset from our current database, doing some data exploration, future engineering, that we can use different types of data that has to be cleaned, transformed, reducted. Also, if there is missing data, we have to fill it. For example, we have different seismic signal, we have different variables, latitude, strain release, depth, energy, GPS signal, so we can see the inflation or deflation of the ground in the long and the short term. We can see also the tilt signals, incline of the ground, even slight variation of microrads. We can see that hours before there is a variation in all these signals that our model can can see this pattern, this complex pattern around all this data. So in this part, the model construction, we have to find some models that fits for our research. We have to train it. We have to optimize testing and evaluating all the models we choose, so we can compare it and choose the one that fits the best for us. The model output is divided in 3 states: rest, an alert, and the upcoming eruption. The upcoming eruption is divided in 2 main categories: the summit event, which are the most common one, and the intrusive event. An intrusive event is really dangerous because it opens a fracture on the flank of the volcano, and this can lead a low altitude eruption around social and commercial area, and so it's really important to predict this event. Thank you for your attention. If you have any question, you can contact me on my email. Bye everyone.